This is section 11.2, covalent formulas and nomenclature. And the objectives here are be able to know the Greek prefixes from 1 to 10, write formulas for binary covalent compounds, and name them using the proper nomenclature. When they talk about nomenclature, they simply mean like the systematic approach. It's a way of following the rules to name these things. And so all the things that we've done in chemistry, naming wise, would be considered to be the nomenclature. And unfortunately, it varies for different compounds, because in chemistry there's just a lot of different compounds that can't all be named the same way. When we were naming ionic compounds, we used, the cation, sometimes with a Roman numeral, followed by the anion. But unfortunately, with covalent ones, we can't do that, because even if we tried using Roman numerals, there are some times where even with the same oxidation numbers, you get different compounds formed. So there has to be something that indicates that a little bit better than what we did in the last chapter with ionic compounds. So the way that we do this for the covalent compounds, there are a few rules. The first rule is kind of similar to what we already did. Write the first element in the formula just like you normally would. So whatever it is, just write it down, and there's nothing different with that. The second formula, we're going to name it like we did anions. Now, technically, it's not an anion. These aren't ions at all. But we name it the same way. And in other words, we're going to change it to end in IDE. So if that was oxygen, we'd change it to oxide. Or chlorine, we'd change it to chloride. But you can also have those same things come first sometimes. So that's a little bit different than it was with the ionic ones. Then, to indicate how many of each one we have, we use the Greek prefixes, and we'll talk about those here in just a little bit. But we always use the Greek prefixes to indicate how many of each atom there are. Except that we do not use mono if there's only one for the first element listed. We use mono if there's one only, in the second element. But if there's only one in the first, we just ignore that particular word. That's really the only kind of exception to that naming with the prefixes. Here's our Greek prefixes. A lot of these you're probably familiar with. There's a few that might be a little bit different, or that maybe you've never heard of. But 1, mono. 2 is di. Make sure you use di, not bi. I mean, there's sometimes 2 prefixes that can be used for that. But use the di. That's the one we're using. Tri for 3. This one is probably a little different. You may not be familiar with tetra, but tetra is the prefix for 4. And then after this, with all of these here, these would be prefixes just like you would use in math if you were talking about, figures with different numbers of size, pentagon, hexagon, and so on. Then the prefixes just match up with everything that you had there. So you have penta, hexa, hepta, octa, nona. That might be an more unusual one. You may not have used 9 very often, and then deca. But be familiar with these prefixes. And like I said, really, you're probably just looking at a couple that you're not super familiar with, and then most of them are ones that you have used in math already. Alright, so let's name these. Let's look at the first one, the first part of it, the first element. And you see it's nitrogen, and there's 2 of them. So we need to say, hey, 2 di. So we'd say dinitrogen. And then for the second one, we always want to have a prefix for. So we would say it's mono. And usually we don't put 2 O's in a row, so it's just going to be monoxide. And remember, we're always changing that last part to IDE. And if we look at the second one, there's only one N, and when we used mono for the oxygen on the one up above, but we don't do it if it's the first element. So we would just call it nitrogen. So this is just going to be nitrogen monoxide. So the next one, okay, we've got 2 nitrogen. So once again, we're back to the dinitrogen. We need a prefix meaning 4. That's the tetra. Okay, tetroxide. Okay, The next one is sulfur. Since it's mono, we don't have to write it, it's just one, sulfur. And then we need a prefix meaning 6, and that's hexa. Hexafluoride. The next one, you're probably familiar with this one. You would simply call it carbon, and dioxide. And then our last one, we would call it diphosphorus. 5 is pent, so pentasulfide. Alright, so your turn to practice. Stop the video and go ahead and write down the answers to these 5 right here. Write down the names. Okay, so for the first one, be carbon monoxide. Then we have phosphorus. There's 3, so we'd say trichloride. We have boron. Once again, trichloride. We have sulfur, tetrafluoride. And then the last one would be dichlorine monoxide. Okay, hopefully you got all those right. Alright, let's talk about writing formulas. This is actually easier because they tell you how many there are. If there's no prefix, that's a mono. Here it tells you the prefix there. So you just simply look at what it is. Alright, it's nitrogen, there's 1. Tri means there's 3 Cls. Okay. You got dinitrogen trioxide. Well, now we know there's 2 nitrogens. We know there's 3 oxygens. Carbon tetrachloride, so mono, if there's nothing, it's 1. Tetra is the prefix for 4, so we've got 4 Cl, so CCl4. And the last one, sulfur hexafluoride, we'd have sulfur, 1, and fluorine, 6. So there it is. That's all you have to do. Pretty straightforward, pretty simple to write these forms. A little more complicated to name them, but easy to write them. Alright, why don't you try these? So stop the video and see if you can write these formulas. And you can check your work here. Sulfur trioxide, SO3, then N2F4, oxygen difluoride is OF2, then N2O5, and the last one, P4O10. And that is the end of this section.